Today's lesson is on multiplying and dividing radicals. First, we will multiply. When you are multiplying radical terms, follow these steps. 1. Multiply the coefficients. Or the outside terms. And then multiply the radicands. Or the inside terms. So on 4 root 3 times 6 root 2, we're going to take the 4 and the 6 coefficients, and we're going to multiply them, and that gets 24. And then we're going to take the 3 and the 2 radicands, and then we're going to multiply those to get 6. Now step 3 says simplify if possible. Root 6 breaks down to 3 times 2. There's no pairs of 2 in that, so I know that 24 times the square root of 6 is my final answer. On the next problem, my coefficients are 2 and 4, so I multiply 2 times 4 to get 8. My radicands, 3 times 15, multiply to get 45. Step 3 says to simplify if possible, so I'm going to take 45 and see if I can't break that up. It looks like 9 times 5, 3 times 3 times 5. So there is a pair because it's a square root, so we're looking for groups of 2. So the 3 comes out, the 5 stays home, but don't forget that you also had the 8 out front. So we're going to multiply those two together to get 24 square roots of 5. On the next problem, we have 2 and 5 as coefficients, so we're going to multiply those to get 10. Under the radical, we have 3y and 2x, so I'm going to multiply both radicands. 3y times 2x, that's 6xy. 6xy would need to reduce step 3 if possible. So 6 breaks down to 3 times 2 times x times y. It doesn't look like there's anything that's going to have a group of 2 there, so this is my final answer, 10 times the square root of 6xy. So when you raise a radical to its index, we have the following property. The nth root of a raised to the n is equal to a. That means if you're raising a radical to the same power as the index, the exponent and the index basically undo each other. So let's do this first problem. We have root 3 times root 3, which if you multiply the two insides, you get 3 times 3. Well, look at that. That's a group. A group of 2 gets to go out, and then you just have 3. One short way to do this, if you applied the rule, root 3 times root 3, because root 3 is the same, you could have written root 3 squared. And because the little index is 2, the 2 index and the 2 exponent undo each other, and you're still just left with 3. Either way you want to think about it, you're still going to get the answer of 3. On the next problem, root 7y times root 7y. If you multiply the insides, you get 7y times 7y. If I rearrange that, that's 2 7s times 2 y's. So the 7 gets to go out, the y gets to go out, and your answer is 7y. Now there's a short way of doing that. We could have just written this as root 7y squared, and the square root index and the square undo each other, and you're still left with 7y. Either way you want to do it is fine by me. On our next problem, we have the square root of 5 minus y times the square root of 5 minus y. Now even though 5 minus y is a binomial, the entire term 5 minus y in the parentheses has a group of 2, and my final answer is 5 minus y. Another way you could have looked at that is because it's multiplying by itself, you could have written it the square root of 5 minus y squared, and the little 2 index and the squared undo each other, and you're still left with 5 minus y. Now on this next problem, we have the fifth root of 150x squared y to the fifth. Okay, I don't really want to write that out 5 times and then circle the groups. I definitely don't want to do that. I really want to take the shortcut that the 5 index and the 5 exponent undo each other, and you're just left with 150x squared y. On our next problem, we don't have an index, but we know that any invisible index is a 2. The 2 index and the 2 exponent undo each other. They're like opposites, and my final answer is just 5. Now the last one is a little bit tricky. The reason it's a little bit tricky is because we have this coefficient out here. So we have 4 times the square root of 8a squared. If I want to write that out twice, remember we multiply our outsides together, so that's 4 times 4, or 16. And then I can multiply my 2 insides together. That's the square root of 64a squared. The square root of 64 is 8. The square root of a squared is a. So when I multiply 16 times 8a, I'm getting 128a. One other way you could have done that problem is you could have distributed the square root of both of the bases. We have 4 squared and then the square root of 8a squared. On 4 squared you get 16. On 8, the square root of 8a squared, the radical and the exponent undo each other, and then I still get 128a. Either way you can do it, you're still going to get the same answer. Now when multiplying more than one term of radicals, we need to use the distributive property. So on this first problem, we have a monomial multiplying a trinomial. So when I distribute, I need to multiply the monomial to each individual term. So on the first term, any outside multiplies together, well, that's just 3. Any insides multiplies together, and that gets me 5y quantity squared, because there's 2 of the same. On the next problem, we have outsides multiply. Well, there's an invisible 1, so that's 3 times 1, or 3. Insides multiply. Now I can't write it as a squared like I did on the first one because it's not exactly the same. So I'm just going to go ahead and multiply the insides. And on the last one, 3 times negative 2 is negative 6. And the square root of 5y times 3 is 15y. Now I still need to simplify here. So the 2 and the square root undo each other. So I just have 3 times the inside, 5y. On the second term, 5xy. Well, 5 is prime and there is no groups of 2, so that's going to stay as is. And 15. 15 might be able to reduce here. 15y. 3, 5. Oh, you know what? They don't have any groups, so they're going to stay the same as well. The last thing I can do is just multiply on the first terms to get 15y plus 3 times the square root of 5xy minus 6 times the square root of 15y. On our second problem, we have a binomial, 2 terms, multiplying another binomial, 2 terms. So your teachers may have taught you FOIL in the past. I just like to use the word double distribute. I take this first term and it's going to distribute to both. And then I'm going to use a different color and grab the second one, and it's going to distribute to both. Okay? So that's how you multiply a binomial times a binomial. On the first multiplication, 4 times the square root of 2 times 5 times the square root of 3. Multiply my outsides, I get 20. Multiply my insides, I get root 6. On the second one, I multiply the outsides, so it's 4 times negative 8 is negative 32. Multiply the insides, I'm getting the square root of 12. Let's move on to the green. Make sure that you remember that the negative is stuck to the term behind it, so when you distribute the 2 root 3, you're also distributing the negative. So negative 2 root 3 times 5 root 3 is negative 10. Multiply the outsides. Square root of 9, multiply the insides. Negative 2 root 3 times negative 8 root 6, multiply the outsides. Positive, because a negative times a negative is a positive, 16 times the square root of 18. Okay, well nothing has like terms right now, so nothing can add, but I probably need to spend some time trying to reduce. The square root of 6 breaks up into 3 times 2, and that doesn't have any groups of 2, so that's going to stay 20 times the square root of 6. 12, oh, that does have a group of 2, so the 32 stays on the outside. Then the 2 comes out as one group, and then a root 3 stays home. The square root of 9, that's a perfect square, that's just plain 3. Make sure you don't write square root of 3. A lot of times students will think it's a square root of 3, but 9 is 3 times 3, so the 3 goes out of the house, nothing left inside the house. And then 18 is 9 times 2, 3 times 3 times 2. So the 3, group of 3 comes out, I'm getting 16 times 3 times the square root of 2. Let's simplify a little bit here. I have 20 times the square root of 6 minus 64 times the square root of 3. In green I have minus 30 plus 48 times the square root of 2. At this point I look at all of my square roots. Are any of these square roots the same? Well, this one doesn't have a square root, but none of them are like terms, so this is my final answer. On our next problem, we have a binomial squared. Now, a lot of students are tempted to do this, and this is a mistake. They'll try to square the first term and square the second term. You cannot do that at all because of this minus sign. If there's a minus or plus, you can't distribute an exponent over a plus or minus. What we must do instead is when you are squaring something, that just means multiply it by itself. So we're just going to multiply this out by itself, write it out twice, and double distribute like we did on the previous problem. I'm going to take 3 times the square root of x and distribute both terms in the other parentheses, and then I'll come back and grab negative 2y and distribute that to both terms in the other parentheses. So in red we have 9 times the square root of x squared minus 6 times the square root of xy. On the green, don't forget to take the negative with your 2 times the square root of y. So negative 2 times the square root of y times 3 times the square root of x is minus 6 times the square root of xy. And on the last one, negative 2 times negative 2, that's positive 4 on the outside. Root y times root y is root y squared. Let's go ahead and simplify what we can. In the red, I know the square root of x squared, the square root and the square undo each other, and I'm just left with x, 9x. These two middle ones, I can tell you that they're going to combine negative 6xy minus 6 more xy. They're like terms. There's nothing that can reduce, but they are like terms, so we're going to add them together to get negative 12xy. And then on the last term, I have plus 4. The square root of y squared undoes each other, and you're just left with 4y. And that is my final answer.